right, we are back. This is Techmath2. We're working on chapter 15, but out of the blue book. So we're doing out of the Techmath1 book, chapter 15, powers, roots, and logs. Powers and roots should just be review. We've done those already extensively in this course and in 115. So hopefully this will be pretty straightforward for everybody. So let's take a look. 247 to the 8th power. So we pop in 247. We hit the caret key. That's just above the divide by sign. And then 8. And then hit enter. And so we get this on our readout. Let's take a look at what our calculator says there. So 1.385401412 e to the 19. So what does that mean? Well, that means that there's 19 places after the decimal point. So not 19 zeros after the last number, but 19 places after the decimal point. And so let's see, it says round the first factor to 2 decimal places. So they don't want it rounded, they just want 1.39, this part rounded, but then times 10 to the 19th power. So that means we would add 19 places to that. And that's how many zeros it would be for the number. All right. So the next one is 0.039 to the 20th. You pop that into your calculator, and that's going to be really small. That's 6.63 times 10 to the negative 29. So 6.63 times 10 to the negative 29. All right. What about really tiny numbers like this? To the negative power, remember that drops it down to the bottom, so it's 1 over 12 to the 4th, but you don't have to put it in like that. You could key it in 12 caret parenthesis negative 4 end parenthesis, and then hit enter. So to the negative 4 power. Remember, negative is on the bottom by enter. Don't use minus sign by accident. Use the negative on the very bottom. And are we rounding in the same fashion here? Let's see. They want it to round to millions. Okay, so this time they don't want this. We have 4.822530864 e to the negative 5. So what does e to the negative 5 mean? Well, that means times 10 to the negative 5th, which means I'm going to take this decimal and move it 5 places to the left. So 5 places to the left, 1, 2, 3, 4, 5, that actually adds 4 zeros in front. So we have a decimal, 1, 2, 3, 4 zeros, and then the number 482253, and so on. So now let's go tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths is right there. They want me to round to millionths. So I look at the number to the right of it, that's a 2, and that's not enough to bump it up to a 9. So it just stays 0.000048. And that is my answer. Same dog, different fleas, right? 8.9 to the negative 5th power is 1.79. 79081188 e to the negative 5. So that's times 10 to the negative 5th. So that's 5 places again to the left. So that adds 4 zeros, a 17908. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths. This time that is enough. That 9 is enough to bump the 7 up to an 8. So 0.000018. Okie dokie. Let's take a look at this. So this is 3 to the 1/8 power. Remember I showed you that when we did weird roots. So 3 to the caret parenthesis 1 divided by 8 end parenthesis. And so that is 1.1472029, which is, oh wait, they didn't want me to do that. Doggone it. They just wanted it as a decimal. So write each one as a decimal. Shoot, I went right to the answer. They didn't want this answer. They wanted me to go like this. 3 to the 1/8 power, which that's not a decimal, that's still a fraction, I understand. So we do 1 divided by 8 on our calculator. That is 3 to the 0.125. This is what they wanted. They didn't want the actual 1.47. Jumped the gun. Sorry about that. That's probably 5.3. They'll have us actually evaluate it. And so to the 1/5, so do 1 divided by 5 in your calculator, that's 0.2. And so this is 47 to the 0.2 power. So they didn't actually want us to evaluate the root. They just wanted us to express it as a decimal. All right, so then let's look at evaluating formulas containing powers like 5.3. We'll just do number 26. .3 rather, not 5.3. 15.3, number 26. And so they give you a formula, and then they give you, so they said I is equal to K P to the 1.5, but then they tell you K is 0.001, P is 19. Okay, so you do I is equal to 0.001 times P to the, P is 19 though. So times 19 to the 1.5 power. And you just type that all in your calculator, all in one shot. If you wanted to do order of operations, you would do 19 to the 1.5 power first and hit enter, and then multiply by 0.001. But your calculator can handle order of operations, so you can just type in 0.001 times 19 power 1.5. And then hit enter. And that is 0.0828190799. And they don't want that many places. They just want it to 10 thousandths. So tenths, hundredths, thousandths, 10 thousandths to right there, 0.0828. Okie dokie. And then the second one, B is equal to TV to the 0.4 power. But then they give you all the information. T is 400. You do times. V is 100, so 100 to the 0.4 power. So you click that into the old calculator and round to a whole number, it said for B, so 2,524. 2,524. Okie dokie. All right, on to 15.4, powers of 10 with decimals. So we're going to look at 30 and 36. So again, just you're taking things. Lots of calculator on this this one. So this is going to be, make sure you got fresh batteries in your calculator before this test. So 30 is going to be 10 to the 3.25 power and 10 to the 3.9837 power. And round to a whole number. So you just pop those into the calculator just like I had said before. 1778 and 9,632. So just caret key, 10, caret key, 3.25, enter. All right. Then 36. This one is a little tougher. So 35,700 They want to know 10 to what power will give me this. So 10 to some power gives me 35,700. So this is actually going to be, convert these powers 10 around each to 4 decimal places. So you have to know about logarithms in order to do these two problems. You can't just, if you were guessing and checking, it would take you all day. Like to say, well, I know it's between 4 and 5, and then let's try 4.5, and then let's try 4.55, and so that would take forever. So I don't want you to take forever. So I'm just going to show you logs now, even though that's the next section. Logs are just a fancy way of writing exponents, and they're all keyed into your calculator. They're all entered into your calculator. So when you think of 10 to the second power, that's equal to 100, right? So 10 to the second power is equal to 100. If I want to write this as a log, I would go log base 10 of 100 is 2. So look at where all the components go. The exponent goes over by itself. Power, right? Power is, it's lonely at the top. Powerful people all by themselves. So all by itself over here, the power. This number goes right here, and this base is right there. Now, math people, if you just see log, like on your calculator, that means log base 10. Math people usually write it, but the calculator code people just said if it's log, that's base 10. If it's ln, that's the natural log. That's base e, log base e. And so they use that in business models all the time. They'll use the natural log. Okay, so now keep this in mind. Now let's transform this. We'll call that x, like the missing number is x. So 10 to the x power is equal to 35,000. So if I wanted to figure out what that power was, I would just do this. I would say, okay, well, log base 10 of 35,700. What this is asking is 10 to what power gives me 35,700. And so that's x. So for this problem, to find the exponent, to write this as a 10 to some power equals 35,700. To find this power, you just do the log of 35,700. So log, log 35,700. That is 4.552668216. That's equal to x. Now they only want it to 4 decimal places, so they 1, 2, 3, 4. So we'll make it a 7. So look, if I want to write that, it's 10 to the 4.5527 power is approximately 35,700. If you checked it, because we left all this part off, it won't be exactly 35,700. It'll be close though. So the answer for 36 is 10 to the 4.5527. That's equal to 35,700. All right. The other one they want us to do is 69,699. 69,699. So how would I write that? I would do the same thing. Just take the log of 69,699, and that's 4.8. So 10 to the 4.8432 power is about 69,699. Again, because we didn't put all of the places down here, it won't be exactly that. If we check it back right now, 10 to the power 4.8432, it's close. It's 69,695. So why isn't it 99? Well, because we truncated off this information following. If you put that information in, we'd end up with that 9. Okie dokie? Okie dokie. So logs are really just a fancy way of writing exponents. So don't let those throw you. Let's take a look at 15.5. Common log is base 10. So the log of 291 is, here we'll look at 40. On 15, what are we on? 15.5. So let's look at 40. They have this down already. They have 10 to the 2.4639 power is equal to 291. So then they say, well, that means the log of 291 is, well, that would be the 2.4639. All right. So here, let's do one like 48. They have 0.0097 equals 10 to the negative 2.0132. And they want me to write this as a logarithm. So write it as a log, like in this form. Logs are just a fancy way of writing that. So what I'm going to do is I'm going to move this. I'm going to put this first and this second so it looks like my little 10 squared equals 100 up there, okay? So we get 10 to the negative 2.0132. That's equal to 0.0097. Now let's transform it into a log. So look at where the pieces go. The base goes down there. So log base 10. The base goes there. The number that you're after goes next, so 0.0097. And then the answer, the power, goes over here by itself. So I move that here by itself. Having like this framework with easy numbers, it's a good thing to write down when you're doing this. Do you know what I mean? I always think of on Friends when Joey says, I'm going to get into the map. That's how I rearranged it. I'm getting into the map. So we put that, Joey was never in England. He had to put the map on the ground and then stand and point in the direction he wanted to go, and then he followed it that way. So same thing. Some people, you don't need to do that. Also, another thing you can leave out, this is optional, you can leave that 10 off of there. When you just see LOG, that means log base 10. So if you don't have it down, it's not a big deal. All right, and then let's do part B here on 48. Again, you will likely get the hang of this pretty quick. And so look, it's just log, we'll leave the 10 off this time, of 651,000 equals 5.8136. And we took it from an exponential to a log. Logs are just a fancy way of writing exponents, okay? So now let's go to solving 5.6. They want us to solve a log problem. So let's do that. So we're going to solve 0.016 is equal to 10 to the t power. So t is equal to what? And 10 to the b is equal to 81,900. And b is equal to what? So when I'm doing this, let's rewrite it. 10 to the t is equal to 0.016. So let's see. That is the log base 10 of 0.016 is equal to the power. So really all we have to do is click in our calculator log 0.016. And so you pop that into the old calculator, that kicks out negative 1.7959. Okay? Same dog, different fleas, right? So we've got log base 10 of 81,900 is equal to b. And so that's just my calculator. Just stick that in, log 81,900, hit enter. That's going to be a bigger number. That's going to be 4.9133. All right. How about if they go the other way, like number 60? Let's take a look at number 60. So number 60 is log of 1290 equals v, and then find v. So remember what this is. This is base 10. So, oh wait, we don't even have to do that. You just stick it into your calculator, I think, right? Round to hundreds. No, yeah, they already have it set up. Never mind, there isn't any work. There isn't any. You don't have to transform it. I thought we were gonna have to go here. I thought we were missing this number, not that number. So you don't have to do anything. You don't need the base 10. You just literally pop that into the old calculator, and you get v is equal to 3.11, and the other one, log base d is equal to negative 0.207. Here we go. So this one is going to require us to do something. That was just pop it into the calculator. This one, we have to rewrite it. So we're going to go from log back up into exponential. So what was this going to look like? Well, look, the 10 goes there. The power goes on to the 10, so negative 0.207 equals, and then that number that was 100 on this one, it's d on this one, goes there. So now I have to tick that into my calculator, 10 to the power negative 0.207, and that gives me 0.621. 0.621. So that one is a little trickier because you got to take it out of log format and put it into exponential and then do the exponents on your calculator. This one, you didn't have to change anything. You just had to type in log. So if they have log of the number equals the variable, you just type it in as it is. If they have log of the variable equals a number, you have to reset it into exponential to figure it out. All right? Lovely, lovely.